Alright, hello. Today we're doing FAQ number 7. First part asks for a free body diagram. So I'm gonna draw the car or the car, yeah. So it's acting with an f of g. There's an f of n from the surface, and then it's being pulled towards the center by centripetal acceleration. And those are the three forces acting on it. Alright, going on to part B now. Asks for an expression to find the normal force on the cars. So first I'll just do Fnx equals f of c. So I'll just do Fnx equals mv squared over r. But then r is just equal to h tan of theta. So that's just Fnx. For Fny, it's just equal to mg. So I can use the Pythagorean, the Pythagorean theorem, which is Fnx squared plus Fny squared. So I take square root of both sides. So now I'm just gonna plug in the values that I got before. So Fnx is equal to mv squared over h tan of theta squared plus Fny is equal to mg squared. That's it for part B. So now for part C, she's asking you to find an expression for f of c. So you know that f of c is equal to f and x. So since that's only force, you know that f of c must be equal to mv squared over r. But r is just equal to h tan theta, so it's just mv squared over h tan theta. That's part C. Alright, go to part D now. So part D asks for an expression for v at the given quantities. So it's just going to be f of c equals f and x. So f of n cosine of theta, that's what f and x is equal to. F of c is just mv squared over r, but then r is just h tan theta. But then f of n is also equal to just mg over sine theta. And so I'm going to go up here now. So times cosine theta right here. So mv squared over h tan theta is equal to mg cotan of theta. I multiply that over. M's will cancel out. So I just get v squared equals gh cotan theta tan theta. These cancel out with each other, so I just get v equals the square root of this radical gh. That's it for part D. Alright, part E asks to find a Vmax if there's an introduced friction now. So I'll start off with the y direction. So I know that it's f n y minus f of g minus f s y, because it's, yeah, equals 0 because the object's not flying. So now I can expand this. So f n sine theta minus f of s expands over to f of s y expands to f of s cosine of theta. So I'm just gonna add fg over to the other side, but fg is just the same thing as mg. And so now I can just f of n sine of theta. F of s is just the same thing as f of n mu s cosine of theta equals mg. So then now I can just factor out an f of n. So I'm left with sine theta minus mu s cosine of theta equals mg. So I'm left with f of n equals mg over sine theta minus mu s cosine of theta. So that's fn. Now I'm going to solve for the, let me make this a little smaller so it fits better. So now I'm going to solve for the x direction. So I know it's just f of nx plus f of sx equals f of c. And so here it's just f of n cosine of theta plus f of s sine theta equals f of c. And so now it's just, I will just take this fn I got right here, I plug it. Actually, let me expand f of s first, make it easier. Plus, this is just f of n mu s sine theta equals, I'm going to expand f of c into m v squared v max right here. This should be a capital M because the object has a mass of capital M over r. And so I can pull on f of n, which is just cosine of theta plus mu s sine theta equals m v squared max over r. Should be a capital R. And so now f of n is equal to, f of n is just equal to, f of n is just equal to whatever I got over here. So I can just do mg over sine theta minus mu s cosine theta times cosine of theta plus mu s sine of theta equals m v squared max over r. M cancels. So now I'll multiply the r over, so I get rg cosine theta plus mu s sine theta, all of this over sine theta minus mu s cosine of theta is equal to v squared max. So I take the square root of both sides, and so these cancel, so I just get v max is equal to radical rg cosine theta plus mu s sine theta over sine theta minus mu s cosine theta. That's it for part E. Alright, I'm going to go over to part F, which is just very similar to part E. Find v min, so now the f of s is just switched now. And so I'm going to start off with the y direction, so it's just f and y. Now it's just plus fsy now instead of minus f of g equals 0. So I'm going to expand this, it's just f of n sine of theta plus, I'll extend this to f of s cosine of theta is equal to f of g. So over here it's just f of n sine theta plus f of n mu s cosine of theta equals, expand this to mg, pull on f of n. Now it's just going to be equal to sine theta plus mu s cosine theta equals mg. Divide that over. Save a little space, so just delete that there. Bring that a little closer. So that's what fn is. So now I'm going to set it in the x direction. So now it's going to be fnx, fnx minus fsx this time, because now it's pointing the opposite direction, equals f of c. So now it's just fn cosine of theta minus f of s sine of theta. F of s sine of theta equals f of c. So over here it's just f of n cosine of theta minus f of n mu s sine of theta equals mv squared. This is v min. This should be a capital M, not a lowercase m over r. I can factor on f of n on the so I'm left with cosine theta minus mu s sine theta. Now I can just plug my f of n that I got over there, so I just got mg over sine theta plus mu s cosine of theta, all of this times cosine of theta, minus mu s sine of theta equals big M v squared min over r. M will cancel. I multiply r over to the other side, so I would get rg cosine of theta minus mu s sine theta all over sine theta plus mu s cosine of theta equals v squared min. So I want to stick v squared, so I take square root of that. This out cancel out, so I just get v min equals all of that. That's it for part F. Alright, now for the last part G, it just says to derive the function and prove that it's true. And so first thing I want to start off with is saying that net force equals F of C. So I say that net force equals mv squared over r. Should be v max. And so net force is equal to m. And so the v max that we got before was just radical r times g cosine of theta plus mu s sine of theta, all this over sine theta minus mu s cosine of theta. This is all under the radical. Square it. All of this over r. So net force is equal to, this will cancel out with that, so it's just going to be mrg or rg cosine of theta plus mu s sine of theta, all of this over sine of theta minus mu s cosine of theta, all of this over r. This answer cancels out with that one, and so I'll get that net force is equal to mg. My bad for writing these all as lowercase. They should all be uppercase. It's a habit. It's gotten used to. So it should be mg cosine theta plus mu s sine of theta over sine of theta minus mu s cosine of theta. However, I can divide every single term by sine of theta. So I can multiply by 1 over sine theta to the numerator and denominator. Parentheses. So doing that, I'll get that the net force is equal to mg times 1 over cosine over sine is equal to cotan of theta plus mu s. Sines will cancel, it's just plus mu s over sines cancel out, so it's just 1 minus mu s cosine over sine is cotangent theta. And that's it for this FRQ. FRQ G is now done. Thank you for watching. See you in the next FRQ.